Okay. Get my presentation back up. There we go. Share my terrific. And we'll give it just, let's see, one more minute and we'll get started. But again, I'd love to see, I'd love to find out a little bit about you, what you're teaching in, oh, and there's someone from second grade, all my favorites. And I'll let you know that if you would like to raise your hand, ask a question in the chat while I'm presenting, I am more than happy to do that. I will also be giving you a time for a Q&A when we're done, so we can answer all your questions. We'll give it just a couple more minutes and we'll get started. Okay, teachers. My name is Kathleen Wallace. I'm pleased to be your host and instructor today. I am newly retired from a long career in elementary education. I taught general ed, I taught special ed. I was the teacher of the gifted and talented for a while. And then for a while right before I retired, I was the math coach in a district that had 3 elementary schools. It was a wonderful experience, working with teachers, developing lessons, looking at the math. And now I am a senior consultant for East West Math. We provide staff development, and we also represent a wonderful product called eSingapore Math, which I want to tell you about today. So the first question that I want to make sure that everyone has answered and knows about is, what exactly is a bar model? Sometimes you hear people talk about them like bar graphs. This is something completely different. A bar model is a pictorial representation of the quantitative information in a word problem. A bar model, I like to say, is a visualization of the relationships between the quantities. And when children are working on word problems, and you probably have all had the same experience that I had, and that is that children universally find them very challenging. And it's challenging not only for the students, but for teachers to teach them as well. The essence of what we want the child to pull out of that problem is to find those relationships between the quantities. If a student has been learning in a visual way, which is typical of our program in Singapore Math, we want them to tap into that visualization capacity that they have and use that to help them understand what's going on in the word problem. As I just said, solving word problems is universally challenging. I have not met a teacher who has not told me that that's, if not their biggest, one of their biggest problems, one of their biggest challenges in teaching. And the question that begs the question, of course, why is this? And I would point you to the work of Anne Newman, who is was a groundbreaking educational researcher out of Australia. She did a long-term study with many, many children to find out what is going on. Why is this so difficult? And she discovered that there were five steps to solving the problem. The first one was reading the problem. Second one was comprehending it. Does the child understand the reading that they've done? The next one is transformation, where they take the information that's going on in the problem and turn it into math. The next piece is the process, the actual calculation. And then the encoding is when the child takes the answer to the calculation and puts it back into words. As you can see, I have bolded the word transformation because this is the place that Ann Newman found was where most children have their problems. Children with reading problems, we can usually overcome them by reading the problem to them and helping them. And I just have another guest, so I want to invite them in. Again, we can scaffold them with the comprehension, but it's that transformation process going from the language of the word problem into the language of mathematics that children have issues. I'll just do this right here. So bar models are a wonderful bridge between the problem and the mathematics. They embody, if you will, the actual transformation process. They take the information in the from the word form and put it into the math form. Not only that, but they are so visual, the children can look at them and it serves to scaffold their understanding. And here is an example. This comes from our, this comes from our eSingapore math program. This is an early third grade problem where we're working with children to get them to understand how to do this. And as you can see, Layla has 12 guppies. Brenna gives her 6 more. How many does she have? All of the information from the word problem is clearly drawn and illustrated in the bar model. You can see the guppies that Layla has, the 6 more, and then the all-important piece. This is an essential piece, and this is stressed in our eSingapore math program. Oftentimes the children don't know what the problem is asking or how the question relates to the mathematics. The bar model always has the unknown labeled with a question mark, and this guides the children to seeing what they need to do. It also, I hope you'll agree that this makes it very clear to the children that what they need to do is to add 12 and 6 and find out how many guppies she has now. So here is an example for how we teach a bar model. And I'm just looking, yes, part and part equals whole. That's exactly right. And that we definitely stress that language in the use of the bar model. So here's an example of a lesson taught in the eSingapore math of a third grade word problem.
A toy robot and a toy soldier cost $19. A toy robot and a toy train cost $23. The toy train costs 2 times as much as the toy soldier. How much does the toy robot cost? Let's draw a bar to represent the cost of a toy robot and another bar to represent the cost of a toy soldier. A toy robot and a toy soldier cost $19 altogether. How do we draw the bars to represent the cost of a toy robot and a toy train? We draw the same rectangle for the toy robot. The toy train costs 2 times as much as the toy soldier. The toy robot and the toy train cost $23 in all. How do we find the cost of the toy robot? To find the cost of the toy robot, we subtract this from this. We get $4. This means that a toy soldier costs $4. To find the cost of the toy robot, we subtract this from this. We get $15.
So I'm sure you all noticed this is a pretty complicated problem, although this would commonly be found in grade 3. It's a two-step problem, and it's also got a multiplicative relationship in it. And quite frankly, if I had to teach this using just one of the standard methods, I think I might get a little nervous. But when you see how clear the bar model makes this problem, you see how children can access these more difficult problems and have success with them. Oops. So that last that little video clip was an actual lesson where the children would be doing the initial learning, and then it's followed up by targeted practice. In addition to the lessons and the assisted practice and the benchmark practice, eSingapore Math has wonderful games. And I'm very happy to see that what we do is we bring up this concept of the bar model for grade 1. This is a game from grade 1. As you can see, the bar models generally are a balance, and what that does is emphasize the importance of the equal sign. And this is a very simple rendering of it into a game where the children can see that the two robot heads needs one more. So I'll give you just a quick look at this game for youngsters in grade 1. So there you have an example of how the bar model concept of the two sides being equal, what does this side need to equal the other side, in that bar model format. So we start off pretty early. So someone mentioned part whole. So this is the very beginning of bar model instruction in grade 3, and this is how we teach a part whole problem.
Lala has 8 Mexican stamps and 11 American stamps. How many stamps does she have altogether? We can draw 8 Mexican stamps and 11 American stamps to represent this problem. It is not easy to draw so many stamps, so we draw a box to represent each stamp. We use 8 boxes for the Mexican stamps and 11 boxes for the American stamps. Are there ways to further simplify the diagram? We can just use 2 rectangles, one for the Mexican stamps and one for the American stamps. We want to find the total number of stamps. We have drawn a part-whole model. This part and this part make up the whole. How do we find the total number of stamps Lala has? We add these together. We get 19. So Lala has 19 stamps altogether.
One feature, well, there's so many features that I'm so impressed with, but if you noticed, the as the narrator read the program, it was highlighted in the text. And then there was a connection between the text and the bar model as they built it. And also the step-by-step where the bar models start off with just drawing whatever the pieces are, and then we change that into boxes, and then finally a box that doesn't have the individual units. So we're moving up in a level of abstraction, and the program delineates this beautifully. Here's another one. Now we have a part whole problem with subtraction. Notice those features that I just mentioned.
There were 18 stickers in a box. Alfredo took away 7 stickers. How many stickers were left in the box? We can draw a box to represent each sticker. So we draw 18 boxes. Alfredo took away 7 stickers. How can we further simplify the diagram? We can just use 2 rectangles. One to represent the 7 stickers that Alfredo took, the other to represent the number of stickers left. We do not know the number of stickers left. But we know that there were 18 stickers at first. How do we find the number of stickers left? We subtract this from this. We get 11. Therefore, 11 stickers were left in the box.
And there you go,
There were 18 stickers.
Stepwise. And of course, just as with the previous one, this instruction is practiced with a game. If you notice now, the game is going up a bit in sophistication. Before we had the robot heads, and now we have the abstract numerals. So the children not only are seeing and watching the action of being equal, what they need to do to make the two sides equal, they're also doing a little bit of mental math at the same time. And there you have it. And see the idea of the bar model, that long, narrow rectangle, is used over and over again to help the children. That's consistent with helping them to understand what's going on. And here's a comparison problem. This one is getting a little more sophisticated. Note how on the right side, there are 2 bars that have to be, 2 bars that need to be balanced. So we have to think first, this is a 2-step. So we have to figure out what goes in the question mark and then what goes in on the other side. And here's another example of another game. This is a 2-step problem. As you can see, they start up in the upper left. What is 34 and 10 going to equal? And they pick out the right number. And then going down, we do that. And now we have to make the 2 sides equal. So it gets fairly sophisticated, even for a game. And whoops. And here's another one again. Now we're moving out of addition and subtraction and into 3rd grade. We're looking at the multiplication. So now we're looking at groups, equal groups. So on the left, there are 3 groups of 2, and the child has to recognize that, go down below and figure out what what's the product in that situation, what would balance it. So now we're going to look at, this is a lesson with multiplication, bar models and multiplication. How do we teach these? How do we get these bar models going?
Betty packed 4 oranges into each packet. She had 3 packets in all. How many oranges were there altogether? There are 4 oranges in a packet. and there are 3 such packets. Let's draw a bar model to represent the problem. We draw a rectangle to represent the number of oranges in a packet. How many such rectangles represent the number of packets Betty had? Betty had 3 packets, so we draw 3 rectangles. There are 4 oranges in a packet. We need to find the total number of oranges. We have drawn a part-whole model. Each of these rectangles is a part. Each part represents a group of oranges. All 3 parts make up the whole. How do we find the total number of oranges? There are 3 groups of 4 oranges. So we multiply 3 by 4. We get 12. Therefore, there were 12 oranges altogether.
There we go. So we help the children learn to work with the concept of equal groups. Some children, as they begin, will want to do repeated addition, but the program will help them with that and then push them into the more sophisticated multiplication model. Here's an example of division. Oops. Same idea. We move from the pictorial into the abstract. So we have 18 potted plants. Those plants are represented at first, and for the children who need to, they can just count the potted plants. We have 2 rows. How many are in each row? And you see the pictorial made a little more abstract with the bar model. And of course, we have another game to go with the multiplication and division. So if we have 44 on one side and we can see 4 equal parts on the other side, they have to think in terms of division and finish the problem. So now we can get into grade 4, we start to see more challenging problems. And a lot of these problems, I think without the assistance of the bar model, they may not be accessible to a lot of students, but here's a really interesting one.
Mr. Williams is 193 centimeters tall. Elton is 137 centimeters tall. What is the difference in their heights? This phrase shows that a comparison is being made. Let's use a comparison model to represent this problem. Mr. Williams is 193 centimeters tall. And Elton is 137 centimeters tall. We do not know the value of this. How do we find the difference in their heights? To find the difference, we subtract this from this. We get 56. Therefore, the difference in their heights is 56 centimeters.
And again, these, particularly these comparison problems, they can be very challenging conceptually, but the bar model makes it very clear because they can see the bar, they can see the question mark, and most often the children will know, oh, I need to take away. They know what the operation is, which, as we know, is another big issue in teaching word problems. And we've got a great game to go with it. This one, the same idea. They have to add the 2 and then divide it and figure out what the right answer is. And now we're into grade 5. And in grade 5, those of you who have taught there know that the word problems start to become extremely complicated, not only in terms of having more than one step, but also there's plenty of fractions involved. So here's an idea of how we teach bar models with fractions.
Betty bought a pizza. She gave 1/2 of the pizza to Brenna and 5/12 of the pizza to Kelly. Who received more pizza, Kelly or Brenna? What fraction of the pizza did Betty have left? Let's draw a bar to represent the pizza. How many equal parts should we divide this bar into? We first need to rewrite the fractions so that they are like fractions. 1/2 can also be written as 6/12. So we divide the bar into 12 equal parts. 1/2 of the pizza was given to Brenna. This is equal to 6 out of 12 parts. Five-twelfths of the pizza was given to Kelly. We have drawn the model for the problem. Who received more pizza, Kelly or Brenna? We can see that Brenna received 6 out of 12 parts, and Kelly received 5 out of 12 parts. 6 parts is greater than 5 parts. Therefore, Brenna received more pizza.
There we go. I left off the part about how much they have left, but as you can see, this takes a fairly complicated fraction-based word problem and makes it very clear and accessible. We also have a game for the 5th graders. We don't want to leave them out. So again, they've got to do some mental math and look at the proportionality of the bar pieces that are on the scale. And they get feedback right away. The robot congratulates them, or it tells them try again. So another feature of as I said, our program has instructional videos, and those instructional videos are then followed up by practice, and then we have benchmark practice, and all of the standards, the Common Core standards, are covered in the program. But in addition to that, we have a couple of features. This shows our dashboard. We know that the kids love the games, and in most of the games that they play, there's some kind of a reward system, and our eSingapore Math has one. This is our digital droid. So you've seen the kids collecting coins and tokens and then spending them on different prizes. Our digit droid, I'll show you a little, is where they collect their tokens and spend them. So there's the robot comes down.
You'll get coins after passing the lessons.
We can collect coins.
You can buy energy for me with your coins. I can make gems using my energy. You can buy the tickets and use them to ask me for help while practicing.
So we're going to buy some energy with the
Great.
coins.
Now I have more energy.
So that when we have lots of energy, we can make gems. And then we can use tickets while we're working to get a little assistance with the problem. And if you look here, they can also use the gems to customize their robot. That's the standard robot. They can customize the ears, the head, all of the features of it. So it adds a little fun aspect that I know that kids enjoy. Another feature that I want to brag about is that this is adaptive learning. The children start off by taking a diagnostic test, so we don't have to, they're not going to be working on material that they've mastered. Each child's program is customized based on the answers they gave in the diagnostic test. If they do really well, they move them forward. If they have some places where they've got missing understanding, they will address that. And this is the dashboard where the child and the teacher and the parent can go once. This is where you go first when the program is opened, and it lets you know how you're doing in each of the topics. And then on the right side, we have percentages and levels. The children collect points, which is another incentive for them. And then if they were ready to start learning, up above on top of this chart would be their next lesson. So they don't have to figure out where they're at, what they're doing. The program takes care of that for them. That's where they access their droid. They can look and see what achievements they've gotten, and then there are assignments and more. So I am thrilled that you are with us today. I'm happy to answer any questions that you might have. And I'm also going to move up to the next slide. There is my email address, and I would love to hear from you, and we can tell you about how you can get a 30-day free trial to use the program, to work with your students and see how you like it. So I'm happy to take questions in the chat, or I can you can unmute yourself and ask me the question live. If you're not able to stay for the Q&A, I want to thank you for joining us today. And I hope that you've got a little glimpse into this very powerful strategy for teaching word problems to children. So thanks for joining me. And I'm going to look and see if anyone in the chat has a question. Anything else I can tell you about teaching word problems with bar models to young children? This digital program is fairly new, yes. I'm glad that I'm glad you're here and you found out about it. I'd love for you to take advantage of the trial and see how it works with your students. So please copy down my email address and let me know. If I haven't mentioned it, the program covers all the standards from K to 5, and they go into quite a bit of detail on each standard. Do we offer professional development for teachers with manipulatives or just on? Yes, East-West Math offers all kinds, both in-person and remote professional development for teachers. If you're interested in learning more about the Singapore approach, which of course the manipulatives are an important part of the concrete pictorial abstract approach, we are happy to provide professional development for that. Thank you for that question. I'm glad you're using CPA. That's terrific. I think it's an essential piece of the way that children learn, and also helping them access the mathematics and really deeply understand it. Glad to hear that. CPA is probably the cornerstone of Singapore math. It stands for the concrete pictorial abstract approach. When we teach children new material with math, in any math topic, we start off by using concrete materials, most often snap cubes, any kind of toys. Yes. Oh, you just don't use the acronym. Okay, we call it CPA. Then we move up to pictures, pictorial representation, and then finally to the abstract. I'm finding that it's pretty much opposite the way a lot of traditional math is taught to children in this country. We start off with the abstract, and I think that's where the problems begin. We want to have them have that deep understanding and then introduce the abstract form. But that's terrific. I'm happy to stay and answer any other questions that you might have. I hope that you've all gotten my email address to let me know about where we can get you started to try the free trial with eSingapore Math. That's terrific. Is that you also have a great evening, Arnitra? Yes, thank you for that. I'll look forward to seeing your email. And if you're, thank you, Megan. It's my pleasure. Thank you for joining us today. So, yes, if I'm happy to stay until if anyone else has another question, but I want to thank you for joining us today. And I hope we'll be hearing from you about starting a free trial and finding out about this wonderful program, eSingapore Math. Thank you so much.